So we have the English system, which is used mostly here, and some examples include inches and feet. Metric system is used in the rest of the industrialized world, and some examples include meters and grams. So the SI unit system was created in 1960, so we'd have an international agreement. It's based on the metric system. So SI units are sometimes too large or too small, so we use prefixes to tell us the size. Some examples include millimeters and microliters. That is the Greek letter mu. All right, we'll skip over this to the next one. So this is page 24 in your worksheet packet. So dimensional analysis, this is something you need to know because we're going to use this when we get into moles and stoichiometry. So if you don't learn it now, you're going to have to learn it later. So it's basically changing between units. We're going to use a ratio. So we're going to write equivalent statement. We're going to use the equivalent statement is not used in significant figures. So this can be single or multiple steps. All right, so it's how many meters are 1.5 kilometers. So we're going to look at page 24. And I know a lot of you are used to doing it in biology, but it's important you learn this. So we know that 1 kilometer is equal to 1,000 meters. So we're going to start out with 1.5 kilometers. The thing I want always goes on top. The thing I'm starting with goes on the bottom. Kilometers cross out. I multiply 1.5 times 1,000, so I end up with 1,500 meters. So this has two significant figures, and so does this. So then I'm done. So we want to convert 2.5 liters to centiliters. So we're going to look for the centiliters on your chart. We find that 1 liter is equal to 100 centiliters. So 2.5 liters. We want centiliters. So I put 100 centiliters on the top. 1 liter goes on the bottom. I multiply across, so I end up with 250 centiliters. So this has two significant figures, so does this, so we're finished. So now we're going to convert 5.6 micrometers to meters. So we look for that conversion. So we find 1 meter is equal to 1,000,000 micrometers. So 5.6 micrometers. So that means 1,000,000 is going to go on the bottom. 1 meter goes on the top. So this is micrometers. So that crosses out. So then we end up with 5.6 divided by 1,000,000. So you're going to see something strange. It says 5.6 times 10 to the negative 6. It says e negative 6. So that just means that it's a negative exponent. So it's meters. So this is our answer. This has two significant figures. So does that. So we're good to go. All right. How many seconds are in an 8-hour workday? So we know that, let's see, we start with 8 hours. We know that 1 hour is equal to 60 minutes. we also know that 1 minute has 60 seconds. So we can break it down to 2 problems or 1. So we're going to cross this out. So 8 times 60 is 480. And then we will go from minutes to seconds. We multiply again. So we end up with 28800. So if we wanted one significant figure, we would write 3000 seconds. Okay, so I think that's it for dimensional analysis. You can watch this as many times as you need to.